In this video, I'm going to show you how to insert a node by its index. I'm going to start off by creating our method, and I'm going to call it insert. Insert will take in two arguments. The first is the index, or the location within our list that we want to insert this new node, and then the second one is the value. Okay, so to get started, we have three edge cases. So the first edge case is checking if the index is out of bounds. So what I mean by that is that if the index provided here as the first argument is less than 0, or if it's greater than the if it's greater than the length of our list. In that case, that would be considered out of bounds, so we just return undefined. So I'm going to do if the index is less than 0, or if the index is greater than this dot length, then return undefined. Next edge case is checking if the index is equal to 0. If the index is 0, so if this as an argument is passed in 0, then that would mean that we are wanting to insert, we just insert the new node to the very beginning of our list. And we have a method for that here in our class. So why recreate the whole method altogether when we have it available? So we can just call this method right here. So that's what I'm going to do for our second edge case. I'm going to do if the index is equal to 0, then I'm just going to return this dot unshift and pass in the value here, that second argument, into our unshift method. That will insert the new node, a new node into the very beginning of our list. All right, third and final edge case is check if the index is equal to the length of the list. If that is the case, then that means we want to push a new node to the very end of our list. And no different than how we had a method for this unshift method to push in a new node to the beginning, we have one as well for pushing one to the end of the list, which is right here, the push. So I'm going to call that method right here. So if index is equal to this dot length, then return this dot push and the value that we have as a second argument. All right, so this takes care of all three edge cases. All right, so now let's get down to the nitty gritty. So we're going to start off by creating a new node. We're going to do here, I'm going to call it a new node, and I'm going to instantiate new node and pass in that second argument into this class or this new instance. This creates our new node. Next, we're going to set variables, a loop index, previous and current nodes. Let me start off with the previous node. I'm going to do let, and then previous node. By default, I'm going to set this null. And then the current node, I'm going to set that to this dot head. And then we have a loop index. The reason why, and I'm going to start that off as 0. The reason why I have a loop index is because I'm going to be using a while loop this time as opposed to the for loop, which by default provides an index for us when we set it up. So since I'm going to use a while loop, I'm going to set up this variable here, which is going to keep track of where we are at in terms of the loop. You could also, if you wanted to, you could just call this loop counter. You can just call it counter. All right, but for me, because I know I'm dealing with like a loop, I'm going to call it loop index. All right, so again, we are going to be setting up our while loop. So I'm going to say loop while the current node exists. So here's our while loop. So while we do have a current node, then we can enter this loop. So as we enter this loop, we're going to set up an if statement, and it's going to check if the argument index is not equal to the current loop index, then we're going to update the previous node, and then update the current node, and then update the loop index. All right, so let's go start that off. So we're going to do if the index that is provided as the first argument is not equal to our current loop index, which when we start off is going to be 0, our loop index, then in that case, then we're going to do some updating of these three values here. So first, I'm going to start off with the previous node. I'm going to update the previous node to now become the current node. So it's kind of like here, if you look at this list here, I have 3 nodes, and that's this structure here that we're pushing in 3 values. All right, so when we start off, you can imagine that we have the previous pointer, the prev. Let's see here. I'm gonna set call P as the previous, and then I'm also gonna do current C as current, which would refer to our current index. Oh, this thing's giving me prompts here. All right. So the current index, when we starts off here, and we see that previous by default it's one position behind, which is pretty much at null. So when we start off this first loop and we enter this if statement, what we're going to do is we're going to update, we're going to push forward our previous node forward. So this P, or the previous node, now becomes ends up here with the current node. All right, so that's what we're doing here. So the previous node becomes the current node, which is here at the 7, and we are going to update the current node to now become the current node dot next. All right, so this current node here now becomes current node dot next. So we shift that one a position over to right here to the 14. Okay, and then the same thing happens is that when another loop occurs, when we restart the loop again, a shifting of these 2 positions is going to start. So now P would end up here at the 14, and then the C, which is the current node, will now push forward to the 19. So that's what we're doing here, where we're updating those values. And then next, finally, inside this if block, we're going to update the loop index by incrementing it by 1 by doing plus plus. All right, so that's takes care of that if block. And then now, if we arrive to this else block, the code executed here means that we arrive to the position of our list based off which matches the index that was provided as the first argument. So in that case, what we're going to do is, by the way, here we took care of this if block, right? We updated the previous node, update the current node, and updated the loop index. So now we're here at the else block. So in that case, we're going to make the previous node point to the new node. Okay, so we are going to make the previous node previous node.next equal to the current node that was created. All right, so the way, if we can visualize this, is this previous node.next. Okay, so say, okay, I call list dot insert with the index that we want to insert a new value is at 1, meaning this position here. Okay, we want to push in the value of 5. Okay, so here, if we want to push in a new value here to the index at 14 here, then that would mean that when we get to this else block here, as we're looping, the previous node which would be here, will point to the 7 here, and the current node would point to the 14 over here. So what we are saying is that, if you can imagine that we're saying that the previous node, which is 7, that we want it now to point to the newly created node, which we created here at the top. And remember, when I'm calling this method, I'm passing in a value of 5. So I created a new node here. So this is the newly created node. And so what I want to do is I want to point this previous node, instead of pointing to the 14, which is to the right of it, now I want to point it to this 5. All right. So I know I can't draw a line diagonally, but if you can imagine that the 7 is pointing to the 5 here now. As a matter of fact, I'm gonna make it here in this. Yeah, actually, yeah, I'm just gonna leave it like that. But just imagine that there's a line, an arrow pointing from the 7 to the 5 now. And because what we did here was point the previous node.next to the 5, then that means it's no longer pointing to what it was connected to, which was the 14 here. Therefore, this 7 is really disconnected altogether from this whole list, this list. All right, but it is connected to the 5. So these two are connected to each other, and these two are connected to each other. But we still have to bring these together now. So the way we're gonna do that is, for the next one, the line here, we say make the new node point to the current node. So remember, this is the new node. So now we want to point this 5 to point to the 14. So this way, now all of a sudden we have all 4 of these nodes connected to each other. So that's the way we're going to do that here. Is I'm going to say, so now the new node. Oh, actually, I made a mistake here. This current node was supposed to be new node. Okay, so instead of current node, make sure this is the new node. And now here, to make this 5 connect to the 14, we do new node.next is now connected to the current node, which would be this 14 here. So now at this point, just by having finished this here, now these are connected to each other. So now this is like 7 is now connected to 5, and 5 is now connected to this 14. So now we have a list with these 4 nodes, just like so. And we did exactly what we wanted to achieve here, which was inserting the 5 into this list based on its position, which we wanted to place it at position 1. Okay, but over here, to finish off this else block, we're going to return this, which will return the linked list. And then here at the end of our list, we want the while loop, we want to just return false if we end up arriving here. All right, and that is our insert method. Let's go ahead and test this out. So I'm going to use this here. Just insert with insert at a position of 1, and I'm going to insert the value of 5. And it should draw out this right here. So I'm going to run this code, and let's see. Okay, because we still got a length of 3, and when in reality we should have a length of 4. So the mistake here was, okay, it was right over here. So before we return, we have to increase our length because we are inserting a new node. So we do this dot length plus plus. All right, so let's go ahead and do this again. I'm going to run the code, and let's see. There you go. So now we got a length of 4. Let's go ahead and expand this and see if this draws out this list here. So as the head, we see we got a 7. Okay, so that's here. And if I expand the head, the next node to it should be 5 right here. So let's go ahead and expand the head. And if you look here in the next, you see a node with a value of 5, which indeed is this here. So let's go ahead and expand the 5, which should point to 14. And let's see what happens. And you see here 14, and then the next one to 14 should be 19. So expand the next, and you see 19, and 19 obviously is a tail, so it should point to nothing. If I expand that, you see that next is null. All right, so we took care of, we created an insert method that takes in an index and inserts a new node in that position.